Hello and welcome to another video, where I'm going to take you through question 3 from MAT 2011. Now, I quite like this question, provided you realize some crucial things at the start. You've got y equals x cubed minus x. Well, that obviously goes through minus 1, 0, and 1. If you factorize it, you'll see why those are the roots. But then we've got a general equation of a straight line. But throughout this question, m is going to be bigger than 0, and a is going to be less than or equal to minus 1. Now, our straight line is going to be touching the cubic, yeah? Well, that really narrows down what's going on here. It constrains and restricts a lot of the scenarios, because straight away I'm thinking, well, and I've drawn a few graphs on GeoGebra here, we could have m getting very, very large, in which case a, which has to be less than minus 1, m controls the gradient. It's getting steeper and steeper and steeper. Well, the worst that it could go is go up to minus 1 there. It can't actually get any steeper than that, actually, because if it did, then suddenly that's going to change a so that it becomes more than minus 1, which is a problem. You'll see that, to be honest, as we go through the question. That wasn't immediately obvious to me, that actually there's a ceiling on how big m can be. So I didn't realize that straight away. But I did realize that it's going to be rolling around this curve. And as m is greater than 0, it's never going to go beyond that turning point. And as a is negative, and in fact less than or equal to minus 1, that just means that the x-intercept is more negative down here, because a represents the x-intercept. And as a gets more negative, you can see the gradient gets lower and lower and lower, or closer and closer to 0. And so there's some serious restrictions on a and m here, but not realizing that m is bounded at 2. Well, that can actually cause a few problems in this question. Anyway, let's get on with it. Let's actually get into the guts of the question. But there are restrictions on a and m, so this doesn't just roll right the way around the curve as a tangent. It's actually just rolling round this initial part of the curve. Now, use the fact that the line and the cubic touch when x equals b to show that m equals 3b squared minus 2. Now, you'd be forgiven here, or certainly I made this mistake at first, thinking, if I've got to show that they touch there, I'm just going to make this one equal this one, and then, use the fact that there should be a repeated root, maybe with the discriminant or something like that. Well, actually, it's cubic, so you won't have so much luck there. Find some kind of devious way to show that at b we've got a point which touches. But, well, firstly, this is down here. This is what they've done in part 4. They've essentially used this approach. So that's not going to help you. It's just too awkward to do that. So we're going to have to go for another approach. And it's a simpler approach, really. If I want to find, what the gradient is here, well, the gradient of the tangent and the gradient of the line should have exactly the same value. Now, the tangent to the curve's gradient can be found by differentiating. So I'm just going to go dy by dx is 3x squared minus 1. We obviously know that at the point we're interested in, x equals b, and so dy by dx is 3b squared minus 1. But this, of course, is the gradient of the line. Thus, m equals 3b squared minus 1. It's almost too easy to actually, see sometimes. I was thinking repeated factors anyway when I initially took this, but quite quickly I realized I'm not going to get anywhere with that approach. So I'm going to have to use a different approach, which is that the gradient of the curve equals the gradient of the straight line. Okay, part 2. Show further that a is 2b cubed over 3b squared minus 1. Well, we know they intersect at x equals b, so we're going to have x cubed minus x. That's going to be equal to m times x minus a. Yeah, and here we're just saying, the line equals the curve. But m, of course, we've just found, and we're dealing with the point at x equals b. So x equals b, and m equals 3b squared minus 1. Essentially, I'm just plugging those in. So I'm going to get b cubed minus b is 3b squared minus 1 times by b minus a. And now I'm just going to turn this into the answer. Now, they wanted this in terms of a equals. So I'm going to write this as b cubed minus b over 3b squared minus 1 equals b minus a. But that means that a equals, now if I imagine adding the a over and taking that away, we're going to get b minus b cubed minus b over 3b squared minus 1. And then write this as b times 3b squared minus 1 over 3b squared minus 1. So we have a common denominator. And then take away, when we put it in brackets, b cubed minus b over 3b squared minus 1. And you'll have the answer in the next line, essentially, because you're going to get 3b cubed minus b. Well, write it down, we'll do two more lines. 3b cubed minus b cubed plus b all over 3b squared minus 1. And there's our answer. A equals 2b cubed over 3b squared minus 1. And we've finished. Happy days. Okay, so that was part 2. Part 3 can get a little puzzling, because if you don't realize that this line is just going to be, first, we've got a positive gradient, but secondly, a is less than or equal to minus 1. And what is a? A is your x-axis intercept. That's what it is. How do I know that? Well, just think how this works. When y is 0, x is going to equal a. In other words, x, a is your x-axis intercept, because your x-axis intercept occurs when y is 0. And so they're saying the x-axis intercept is always less than or equal to minus 1. Now, when you think about it, that's going to give you only lines like this. Yeah, a has to be less than or equal to minus 1. That's the case throughout the question. Once you realize that, you'll see, well, okay, what's going to happen as a gets more and more and more negative is that b gets closer and closer and closer to the turning point there. Now, that makes this very, very doable, because we're going to say as a gets very negative, I call it very negative, or let's do it the proper way, let's do it the mathematical way. As a tends to negative infinity, we can say that the curve, well, the tangent sort of curve, or let's say the straight line, or we can just say y equals mx plus a, mx minus a, sorry, touches the curve closer and closer to the turning point. And use GeoGebra if you can't see that. You'll see it very quickly on GeoGebra. GeoGebra is dead useful for these confusing diagram questions. I know you won't have it in the exam, but the more you use it, like regularly, the more you'll see how graphs kind of transform. It's a really good, useful tool. So to the turning point. And so we just need to find the equation of that, the x-coordinate of that turning point, because we want b, yeah? And b is where the turning point occurs. So all we really need to do is y equals x cubed minus x. So dy by dx is 3x squared minus 1. Actually, we could just use this. The gradient gets closer and closer. I mean, this is another way of looking at it. The gradient of that line gets closer and closer to 0, the more negative you get. So you get 0 is 3b squared minus 1. So b is 1 over root 3 plus or minus. But we need to take the negative because b is clearly negative. It's the same way as doing it like this. You're just going to plug b in there and set the gradient equal to 0. So b roughly equals the negative of 1 over root 3. Yeah, think about how the line is acting as a becomes more and more negative. Look at these 3 diagrams, it shows it perfectly. A is minus 1, you're up there. A is minus 2.6, well, the gradient's reducing now, and we're going back that way. A is minus 4.6, we're getting very close to the turning point now. And as A gets more and more negative, M gets closer to 0, and this place where they touch gets closer to the turning point. That one can be quite subtle, though. I can understand how you might not quite see what they're getting at there. Oh, using the fact that this is the case, and this is what I was saying about repeated roots here earlier. You know, my initial thought for part 1 was, oh, I'll just show that when that equals that, we've got a repeated factor. But I've just said use this fact as, and you don't need to prove it. Yeah, because I think that's self-evident. Now I'm going to use that fact. I'm going to say, okay, x cubed minus x minus mx plus ma is going to be equivalent to x squared minus 2bx plus b squared multiplied by x minus c. Then I'm just going to multiply out everything and equate coefficients. Now it's helpful here if you have x times by 1 plus m, so we collect that and we can see the coefficient on x here, plus ma equals x cubed, obviously the x cubes cancel, but we're equating coefficients here, minus 2bx squared. Now let's collect all the x terms together, minus cx squared, and then we're going to have plus xb squared, and then we're going to have minus 2cbx, or plus 2cbx, sorry, and then minus cb squared. And all we're going to do now is we're going to equate the coefficient on x squared. There's 0x squared on this side, but on this side, there is actually minus 2b x squared minus cx squared. Because then we can see by cancelling the x squares that 0 is minus 2b minus c. And so in fact, 2b is minus c. Or c is minus 2b, let's put it the other way around. Done. So that one was quite nice as well. And part 4 is not too bad as well, provided you realise what's going on with the graph. Now, or part 5 is it? Wow, part 5. Did we do 4 parts there? I feel like I've done hardly anything. It's a weird question, this one. It really is. It can sort of be confusing, but actually there's not much to it. Now look at this. These are the possibilities as A becomes more and more negative. Obviously, R is just getting smaller and smaller here as A gets more and more and more negative. It's at its largest area when A is at minus 1. Now you might think, well, where did I get the M is 2 from? I got it from M equals 3b squared minus 1. Essentially, I got it from that. Well, once I plugged all these values in, let me show you what I mean. You can have, we've got a few equations here. Where can I squeeze in my working here? Right. We've got A is minus 1, generates largest value. Now, don't forget that they said A was 2b cubed over 3b squared minus 1. We derived that. And so we can say minus 1 equals 2b cubed over 3b squared minus 1. Times it across and turn it round. 1 minus 3b squared is 2b cubed. Take it all onto one side. Don't be surprised to see a casual bit of factor theorem that you've got to use in the question. That comes up a lot. Because look at this. If b was minus 1, you'd have minus 2 there, plus 3. Sorry, yeah, minus 2 plus 3 minus 1, which is 0. B plus 1 is a factor by inspection. In other words, b equals minus 1 when a equals minus 1. This makes huge amounts of sense because if you look here on this, where is the tangent point now? Where is it touching it? It's touching it at x is minus 1. In other words, b is minus 1 there. So what do we have? We've got a is minus 1, b is minus 1, in which case m, which is 3b squared minus 1, is going to be 2. Once again, you can see it on my diagram and GeoGebra that m worked out to be 2 there. Sure enough, yeah. And let's write down c as well, just for completeness sake. C ends up being 2 as well. And that's because c is minus 2b. And so minus 2 times minus 1 is 2. Now, why have I done all that? Well, it's so I'm basically being asked to find this area here. Now, I've actually got where it crosses here, because we just said that C was going to be 2. And you kind of see that it looks like they're going to meet at 2. And the x-coordinate there is 2. And then we can use our classic little bit of way for finding the area trapped between two curves. We're going to integrate from -1 up to 2, top curve minus bottom curve. Now the top curve, because it was y equals m times x minus a. Remember, m was 2 and a was -1. So this becomes 2 times x plus 1, which is 2x plus 2. And I'm going to take away from that the bottom curve, which is x cubed minus x with respect to x. Simplify it first. We're going to get minus x cubed. 2x plus x is plus 3x. And then plus 2. Integrate it in the normal way. Minus x to the power of 4 over 4 plus 3x squared over 2 plus 2x. Between 2 and -1. And then plug it in. 2 to the power of 4 is 16, minus 16 divided by 4 is -4, plus 4 times 1/2 is 6, plus 4, that's the easier bit done, minus, then we're going to get -1 to the power of 4 over -4, well, I'm pretty sure that's -1/4, plus 3 over 2, plus -2, and we simplify this, we're going to get 6 minus, if you think of this as 6/4, -1/4 plus 6/4 is 5/4. Take away 2 is -3/4. And you get 6 3/4, but that's 27 over 4 as required. And that is the end of that math question. Hope it wasn't too bad. Keep up the hard work and let me know if you're stuck. Keep going.